In this video, we're going to look at independent events. In the formula booklet, you're given a formula for independent events. You are told that two events, A and B, are independent if the probability of A times the probability of B is equal to the probability of the intersection of A and B. So what are independent events? Well, two events are independent if one does not affect the other. So if I throw a dice and flip a coin, what I get on the dice has no effect on what I get when I flip the coin. If I get a 6 on the dice, it has no effect on what I will get on the coin. They are totally and utterly independent events. If you take a tree diagram, this tree diagram shows what happens when you have two events happening. So if you take a look at this branch, this shows you the probability of event A happening. If you go along this branch, it shows you the probability of B happening given that A has already happened. But if these two events are totally independent of each other, this second branch here is really the probability of B, because A has no effect on B whatsoever. So you can say that the probability of B given A, if they are independent, is exactly the same as the probability of B. I'm going to write down another connection between independent events. The probability of A given B is equal to the probability of A, which is equal to the probability of A given not B. And I'm going to illustrate this by the probability of me passing my driving test is A. So I take my driving test on Saturday evening. The probability of me passing my driving test and Manchester United winning, right? Manchester United winning has no effect on me passing my driving test. And conversely, if Manchester United lose, that has no effect on me passing my driving test. So I can confidently say that the probability that I pass my driving test, given that Manchester United has won on Saturday, is the same as the probability of me passing my driving test, which is also the same as me passing my driving test, given that Manchester United doesn't win on Saturday. Here are some typical exam type questions. Question 1. A student is chosen at random from a class. The probability that they have a dog is 0.7. The probability that they have a cat is 0.5. And the probability that they have a cat or a dog is 0.8. A. Find the probability that the student has both a cat and a dog. Well, to do this, I have a formula. I am told that the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersection B. Well, I can put in my values now. I know that the probability of A union B, which is cat or dog, is 0.8. I know that the probability of a dog is 0.7. I know that the probability of a cat is 0.5 minus the probability of both. Therefore, the probability of both A intersection B is equal to 0.7 plus 0.5 minus 0.8. So the probability of A intersection B is equal to 0.4. Part B. With reason, find if having a dog is independent of having a cat. Well, I have a formula for independence. I know that the probability of A intersection B for independent events is equal to the probability of A times the probability of B. Therefore, 0.4 is equal to 0.7 times 0.5. Therefore, 0.4 is equal to 0.35. Those two are not equal. Therefore, the two events are not independent. Question 2. Two events Q and R are such that the probability of Q is equal to 0.8 and the probability of Q intersection R is 0.1. Given that Q and R are independent, find the probability of R. So we can use the formula. The probability of Q intersection R is equal to the probability of Q times the probability of R. Therefore, 0.1 is equal to 0.8 times the probability of R. Therefore, the probability of R is equal to 0.1 divided by 0.8. Therefore, the probability of R is equal to 1 over 8, which is equal to 0.125. Question 3. Given that the probability of X is equal to 0.6 and the probability of Y is equal to 0.5 and the probability of X intersection Y is equal to 0.3, A. Find the probability of X given Y. B. Find the probability of X given not Y. And C. Hence show X and Y are independent. The first thing I'm going to do is draw a Venn diagram to show all this information. So here is my Venn diagram. I know that the probability of the intersection is 0.3. I know that the probability of X is 0.6. Well, there's already 0.3 in there, so the rest is 0.3. I know that the probability of Y is 0.5. Well, there's 0.3 in the intersection, so that gives me 0.2. So they add up to 0.8, so outside is 0.2. Now let's answer the questions. So A, the probability of X given Y is equal to the probability of both X and Y divided by the condition, which is the probability of Y, which is equal to 0.3 divided by 0.5, which is equal to 3/5. Part B, the probability of x given not y is equal to the probability of x and not y divided by the probability of not y. Probability of x not y is equal to 0.3, and the probability of not y is 0.3 plus 0.2. That gives us 0.3 divided by 0.5, which is equal to 3/5, and hence show that x and y are independent. So the probability of x intersection y is equal to the probability of x times the probability of y for independent events. So therefore we've got 0.3 is equal to x is 0.6, y is 0.5, therefore 0.3 does equal 0.3, therefore independent.